So yesterday we ended with these four examples. And this one right here was 9 plus 4, so it was 13. Yes? Okay. And this one was 1/4 plus 16/4, so it was 17/4. Yes? Okay. So we talked about how the two factors are similar. So they're exactly the same except what? One's positive and one's negative. So when you've interacted with that before, we called them difference of squares. Yes? And that was x squared minus 16. Or if I gave you x squared minus 49, you could factor that into x plus 7 and x what? Minus 7. So we knew it right away. But the key word was that it was the what of squares? The difference. So now we need to figure out how to do this where I can find either sum or difference of squares. So what we are going to call these things, and what they were called before were conjugates, but we didn't use the word. But now we're going to have complex conjugates. So complex means they're a complex number. Yes? And conjugate is going to mean one is positive and one is negative. So over here is where you have, those are complex conjugates of each other. You have A plus BI and A minus BI. So exactly the same except what? Positive and negative. So when I FOIL this out, I have minus ABI and plus ABI. So these two things do what? Zero out. Which leaves me with A squared minus B squared I squared. Well, what is I squared equal to? What? Negative 1. So a negative 1 times a negative B squared would be a positive B squared. So now I don't have the difference of squares. I have the sum of squares. So that tells me, remember when I had x squared minus 4, that was x minus 2 and x plus 2. So if I have x squared plus 4, I'm going to have x and x, a plus and a minus, but what's going to be with my 2?
2 and 2.
2.
And 2i.
2i and 2i. Because that I is going to be will make that negative 4 a positive 4. Now, this is called a conjugate pair. If I were to set these equal to 0, I would get x equals negative 2i, and I would get x equals positive 2i. Conjugate pairs happen every time. So if I told you one of the solutions was negative 7i, what also has to be there? Positive 7i. If I told you that 9i was the solution, what also has to be there? A negative 9i. They come in conjugate pairs always. Because when we take the square root of something, it's plus and minus. Yes?
I don't get the for example thingy.
Well, I haven't even talked about it yet.
Oh. Well, I thought you did.
No, I went this way. Haven't even talked about it. Okay, so a conjugate is the same thing. One is positive and one is negative. So if I have 7 minus 8i, the complex conjugate is what? 7 plus 8i. If I have negative 2i, or negative 2 plus I, the conjugate is?
Negative 2 minus I.
Negative 2 minus I. You notice the only sign that is changing is the one in the middle, not the front one. Understand? So if it's negative 2 on one, it's negative 2 on the other. Emma, does that help now? Okay, I wasn't even there yet. So what does that do for us? Well, that allows us to simplify these because I cannot divide a real number by a complex number, first of all. And when I'm done with an answer, I cannot leave an imaginary number in the denominator, ever. So, I'm going to go back here. When I multiplied these two together, I got a real number, yes? I got 13. When I multiplied these two together, I got 7/4, which is still a real number, correct? So I'm going to have to use the complex conjugates to get a real number in the denominator. Yes?
Can you show me how to multiply those?
Not right now. That was on the video, and we will multiply anyway. You just FOIL them, just like your normal foiling. So I have 10 over 2 minus I. Emma, you have to watch the videos when you're gone. So I have 10 over 2 minus I. Yes? Can I leave the 2 minus I in the denominator? No, because I just told you couldn't. So what do I multiply a complex number by to get a real number? It's what? What's the word? The conjugate. Okay, so I'm going to put parentheses around the 2 minus I. What is the conjugate of 2 minus I? 2 plus I. And I can multiply the denominator by 2 plus I as long as I also multiply the what? Numerator. So I need to distribute the 10, yes? So I'm pretty sure I get 20 plus 10i. And now I need to do what with the denominator? I need to distribute as well, right? So 2 times 2 is 4. 2 times I is 2i. Negative I times 2 is negative 2i. And then I get negative I squared. Just FOILed it out, right? And if I do this right, every single time, what is going to happen to my two center terms? They're going to zero out. So now, what is I squared? Negative 1. So I have negative times negative 1, which is a negative times a negative 1, which is a positive 1. So 4 plus 1 is 5 over 20 plus 10i. Now, remember yesterday when I talked about writing these numbers, we had to split them up, yes? We can't leave it all 1 because the I can't be in the numerator, can it? Let's be to the side. When I add fractions that have common denominators, I come together and I have one denominator, yes? So can I pull these apart? Can I make it 20 over 5 plus 10 over 5i? Can I do that?
No.
Why not?
Yes.
Because if I had this, wouldn't it give me that?
No.
Yeah. Okay, so what's 20 divided by 5? 4. Plus 10 divided by 5? 2. I.
So that would be your answer.
That would be our answer.
Over 5?
No, because
No, because then can
it reduced out. So, I'm okay to have an imaginary number in the numerator. I am not okay to have it in the where? Denominator. So if it's in the denominator, I got to use the conjugate to fix it, to conjugate it. So I have 80 over 2 minus 6i.
So you're asking me to do that?
I'm asking you what we need to do. We can do it together. But what do we need to do? We need to do the conjugate.
Times it should be 2 plus 6i.
Yep, and I'm going to write it off to like the middle because I don't want to write it twice. But I have to multiply it to the top and to the, how about to the numerator and the denominator, right? So the numerator is easy. So what do I get?
160 plus 6i.
How about plus 480i?
Yo, how did you get that? Oh, right at the time.
Yep. I got to distribute to everything, right?
Yeah.
So the denominator, I want you guys to try to FOIL it out on your own. Let's see if we can do it. You're just distributing it.
It's not over anything?
No, I just wrote it one time. Like, I just read it once. That.
Okay.
I just read it once. Like, I get lazy with it. Cooper. Try it.
So, are we basically timing the bottom by the top?
No, you're multiplying the bottom by its conjugate.
What's the conjugate again?
The same exact factor with one's plus and one's minus.
So the opposite.
The opposite sign in the center, yes.
Yeah, I think I did it.
So A plus BI and A minus BI. So this was 2 minus 6i, the conjugate is 2 plus 6i. If I had 2 plus 6i, the conjugate is 2 minus 6i.
So we multiply the conjugate to the numerator?
And the denominator. Because if I have like 2 plus 6i over 2 plus 6i, isn't that really just 1?
Yeah.
Yeah. So I can multiply anything I want as long as I do it to both the numerator and denominator, because I'm really not changing the problem. I'm just making it look different. I'm changing its clothes, not its bone structure.
That's a good analogy, actually.
Okay, so when you FOILed that out, you should have been left with 4 minus 36i squared, yes?
Sure.
Because the two middle terms zeroed out. You had plus 12i and minus 12i.
I didn't multiply.
Well, yeah, you should have been. Okay, you should have got 4 minus 12i plus 12i minus 36i squared. Yes?
Hang on. Calm down.
Well, that's what you were supposed to be doing.
Yeah, I know, but I did it wrong. Should be 160 plus 48i over 4 plus 36.
But yeah,
Okay.
we're getting there. Now you're going too far ahead. Okay, what is this negative? What is this I squared? Negative 1. So it's negative 36 times negative 1, which is plus. So my denominator is now what? What's my denominator? 36 plus 4. 40. Now, why did I just make two fractions?
Because you split them apart and they both equal the same exact thing.
Yep. So,
You have to do that?
yes.
You have to split them?
Yes.
Why?
Because remember I said it was A plus BI is standard form yesterday?
Yeah.
They have to have real part and imaginary part. They cannot intermingle.
So we had to
Yes.
two fractions.
Okay. So 480, and can the I go in the numerator?
No.
No, it has to go out to the side. So I'm assuming we can reduce, yes?
Yeah. Well, 40 goes into 164 times.
Yep.
And then
Or
40 goes
460.
into 48 or 480. 12 times.
12 times. That is a weird 4. So you get 4 plus 12i.
Where did the 36 come from?
6 times 6.
Oh. Okay.
Okay. Now, sometimes we could have fractions. Like, I could have that answer. That'd be fine.
Can we do this next one on?
You want to try the next one, Aaron?
Yeah.
Okay.
Whoa. But it's got an ugly number on the top.
So you're going to FOIL the top and the
Ugly.
bottom. What's my conjugate? I'll start you there.
What did you do?
1
The
minus
conjugate on
2i.
both of them then?
No, just the bottom. -1 minus 2i. We only changed the middle sign
Okay.
because it will change everything if you don't. So I'll give you guys a minute to start. Remember, put parentheses around these, yes? Foil it, foil it, foil it. Foil it, foil it, foil it. Alex, are you foiling? Are you multiplying?
Yeah.
Are you distributing?
Yeah.
Get going.
Okay.
You don't act like somebody who wants to get through this quickly.
I do.
Then,
Or-
Cooper, why aren't you taking notes?
You can't reduce this one.
Yeah.
Whoa.
It's completely wrong.
We'll go back through your work. What did you foil right, Austin?
I don't know. I got 4 minus 3 over 2. I.
Okay, but when you foiled, did you get -4 minus 8i plus 3i plus 6i squared? Because you have to foil this.
Oh.
When you get quantities, you have to distribute all the way through, right? And denominator, your plus 2i and minus 2i zeroed out, didn't it?
Oh. So do the eyes go away when you do that thingy?
No, there's still 9.
Yeah.
No, but like on the bottom.
Well, yeah, because I squared is -1.
Can you go over how you got that?
How what? What?
Well, because you got -10 and then a -5,
Mm-hmm.
and I got a -1 and a -2.
Well, okay, did you get plus 6i squared?
No.
I have a -3i and -2i. Should have given you plus 6i squared.
Plus 6 squared. So then it'd
And then the I squared makes it a -6.
So yeah, I got a -6.
So -6 and -4 is -10. Yes?
How did you get rid of the
How
5
did you get 4? It's a -8.
No. 4 times -1 is -4.
Oh, do you times
Which
the
one
whole
are you at?
I did 4 times -1,
Uh-huh.
and then 4 times -2, so -8i. -3 times -1 is plus 3i. -3i times -2i is positive 6i squared.
Okay, hang on. So I'm looking at your answer that you got.
Mm-hmm.
You got -4, -8i, plus 3i, plus 6i squared.
Mm-hmm.
And I got -4. So I put a plus 8 and I meant to put a -8. Plus 3i minus 6.
It should be plus 6i squared. Because you have a negative times a negative, which would be
Okay. So then, how did you get 10?
Because I squared is negative 1. So negative 1 times positive 6 is negative 6. And negative 4 is negative 10. Because it was plus 6I squared. So it'd be plus 6 times negative 1, which would make it negative 6.
Okay, so then you would get negative 4.
Minus 6.
I mean, negative 10 minus 5.
Mm-hmm.
How? Because negative 8 plus a 3.
So negative 8 plus 3 is negative 5.
Yeah, plus a 6. Or
No.
minus a 6.
No. Plus, look up here, Olive.
Oh,
Look.
this is a plus 6.
Yes, it's plus 6 I squared. So look up at my board. So it's plus 6I squared.
Okay.
So I squared is negative 1.
Right.
So negative 1 times positive 6 is negative 6. So negative, that's why my negative's here, 6, and negative 4 is negative 10.
So then it would be negative 2 minus I.
Yep.
So then, okay.
Brandon said he joined us too. Yes. You don't have an option.
Sam, right now all my positions at Matt they're full, but if someone backs out, you're on my wait list. So I probably will have you do a pre-makeup slip just in case.
Okay, so then how did you get a positive 5?
Because it was 1 minus 4I squared.
Because 5 is...
So I squared is negative 1. So negative 1 times a negative 4 is a positive 4.
Okay, that's why. Because I accidentally put a plus on the bottom.
And it will never be a plus because, Olive, it was plus 2I and minus 2I. It should never be a positive before you start. Okay, am I good?
Last thing.
Oh.
Actually, no, you're fine. I figured it out actually as you moved on.
Are you sure?
Yeah.
Okay. Okay, so factor. We're going to go backwards. So before we do it, if I had x squared minus y squared, you would tell me that it's what and what? X plus y and x.
Minus 5.
Okay. So what is the difference between this and this? One's negative and one is positive. So we are going to factor the same way, but what is the one number I can factor? I mean, multiply every single thing by
1.
2.
and change the sign, but not the number.
Negative 1.
Negative 1.
I said.
What do we know equals negative 1? Y squared. So all I have to do in my factors is put x plus yi and x minus yi. So will that change my negative y squared into a positive y squared?
Yes.
Yes. So you're going to factor them exactly the same, but you're going to throw a what on the last factor? An I. Sit. Okay, so I have 12x squared plus 3. I need to factor it. Please
Divide it
stop.
all by 3.
Divide everything by 3, so I'm going to factor out of 3. So that gives me 4x squared plus 1.
Yeah.
So if that's the sum of squares, right? So can I factor it?
Mm-hmm.
So to what? Please stop that, Alex.
2x plus 1.
2x plus
Oh,
I, or 1i, yes?
And then 2x
And 2x minus I. And I FOIL this out. I'm going to FOIL it out and prove it to you. You don't have to. I have 4x squared minus 2xi plus 2xi minus I squared. 0 plus 1. So I have 4x squared plus 1. See that? Okay. So 4x squared plus 25.
2x minus 5i. And then
Emma's got the hang of it. Does everyone else?
Yeah.
Okay, try the next one on your own. Oops, I was going to put plus plus.
Wait, do the first two numbers have to be the same?
Yes. What do you mean, the first two numbers? Like this?
Yeah.
It's a difference of squares, so it has to be exactly the same ones plus 1 minus.
Goes into 8 and 18. So it's 2.
So factor out your 2 and see what you get. Alex, you working on the problem? Cole, you working on the problem?
Yep, I am.
Austin, can you take your bag off the table, please? Thank you. I appreciate that.
He actually was.
Gracie?
Am I not got it right?
Oh.
Oh, I forgot my square. I'm pretty lazy when it comes to showing my work.
I was like, I couldn't figure out what to do with the 9.
Oh,
Does it matter if the negative is before or after? Like whichever problem it's in? Okay, cool.
questions?
No.
No.
Am I good?
Yeah.
Austin, am I good?
Yeah. Austin, are you okay?
Okay, so now we got to solve. So I have x squared plus 4 equals 0. So how am I going to solve that?
You subtract 4 over.
So I subtract 4 over.
So then it would be x squared equals -10. You gotta.
Miss Mick, I'm getting the hang of this. I'm just doing the homework on it.
How do we undo squaring?
You square root it.
Square root. Okay, so x equals, what's the square root of 4? 2. Oh, don't forget the what and what. Plus and minus. And what does this negative 1, what's the square root of negative 1? I.
That's it?
Now, could we factor it? X minus 2i and x plus 2i? And set both of these equal to 0? And I would have got x equals plus or minus what? 2i? Is that what we got the first time? Yes. Now, this I'm going to warn you. When you take the square root, the biggest mistake I get is people forget the what in the front.
The plus thingy.
The plus and the minus. If I factor it, does it come with it? Yes. Don't forget the plus and the minus. Got me? Okay.
Who's phone went off?
Your
Austin.
mom's.
Okay.
Austin.
Children. You're acting like,
Smith, you're not a child.
well, you're acting like it. Okay. So what are you going to do with this one? Are you going to subtract 49 or are we going to factor it?
I subtracted it.
Subtract it. So x squared equals negative 49. And then
Square root it, and then it would be x equals plus or minus 7i.
Oh, yeah.
okay, what about the next one?
Factor it divided by 5.
Well,
Subtract 25.
oh, it has to equal 0. So if you subtract 25 and divide by 5, you get what?
5.
You get negative 5.
Oh.
And then you square root both of them. And then it would be x equals plus or minus square root of negative 5i.
Whoa.
And that.
Square root of 5 I.
Why would there not be no?
Good?
Got it.
Okay. Now, I couldn't take the square root of 5, could I?
No.
Nope. So it's just there. Do you see how I'm shutting my square root with this little line right here? Okay, it's gotten bigger and bigger. I would encourage you. I will tell you that you will see it written like this. Is this the correct form?
No.
Nope, your I should be in the back.
So the i's outside of it?
Yep, the I is outside of it. That's why I put that little bar down so you know what's in and what's out. That's just a personal thing. And that's it.